Welcome, Namaskara. In this video, we'll learn about the different types of MAF sensor. The first type is cold and hot wire MAF sensor. The second type is moving vane meter. I'll be giving a detailed explanation of these two types. First, let me grab my whiteboard which has few diagrams in it.
A few moments later.
First, let's understand hot wire MAF sensor. You can see the MAF sensor body is cylindrical shape and this part is called thermistor. Thermistor is a sensor whose resistance depends on temperature. That means as the temperature varies, the resistance of the thermistor also varies. Now, there is a constant voltage that is being applied to the thermistor. Thus, a current I is flowing through the circuit. In the earlier video, we learned as the airflow increases, the voltage output of the MAF sensor also increases, right? Now let's understand why the voltage is increasing. Here, I have written a sequence. In this, first is the intake airflow. As the intake airflow increases, this air will flow over the thermistor, right? As we all know, if a cold air flows over a hot surface, its temperature will reduce. So similarly, as soon as the air flows, the temperature of the thermistor reduces a little. That is represented here. And I have written as the temperature is reducing, the resistance is also reducing. This is because in the thermistor we have two types, P type and N type. In the P type, the temperature and the resistance of the thermistor are directly proportional. And in the N type, the temperature and the resistance are inversely proportional. Here I have taken P type as an example. That's why as the temperature is decreasing, the resistance also is decreasing. After this, I have written increase in temperature. This is because in electronics, we have a fundamental law called Ohm's law. We can use this Ohm's law to explain all the simpler circuits in the electronics. And according to Ohm's law, the voltage is directly proportional to current and voltage is directly proportional to resistance. And if we take the right hand side, the current and resistance are inversely proportional to each other. That means if in the circuit there is an increase in resistance, then the current will automatically get reduced. If we observe increase in current, then the circuit resistance must have reduced. That's why we have an increase in current due to the reduction of resistance. And as the current increases in the circuit, the thermistor temperature also increases and the resistance also increases. Thus, we come back to initial point. As the intake airflow increases, the temperature reduces, circuit is always compensating to the rate of change of temperature, that is rate of change of resistance. So, here MAF sensor, according to the rate of change of temperature, it is managing the rate of change of current and it is connected to a voltage divider circuit or an integrated chip which will give us the voltage scale output. Now we understood hot wire MAF sensor. Now the cold wire MAF sensor working is exactly like hot wire MAF sensor with an addition of IAT sensor, intake air temperature sensor. Why we have included intake air temperature sensor is because we all know the mass of the atmospheric air is dependent on factors such as temperature, altitude and density. And the different driving scenarios such as it may be a colder day or a hot summer, it can be a hilly region, or you are driving near the coastal area where you are at mean sea level. These parameters will affect the density of air, thus affect the mass of air that is entering the intake system. So by having another reference sensor, we can get the accurate AFR ratios. Let's understand the advantages of having hot and cold wire MAF sensor over moving vane meter. The main difference between these two is, first one is non-contact sensor and the second one is contact sensor. In non-contact sensor, we don't have any moving parts, that is we don't have any mechanically moving components. The sensor won't undergo any wear and tear over the period of time. Thus, this is almost maintenance free. Since we don't have any moving mechanical parts, this sensor is fast and accurate. In the earlier video, we understood that there can be a grime, oil or grease deposit on the sensing part of the MAF, right? Now, how to clean MAF sensor? In the market, we get MAF sensor specific cleaners, or you can have an alternative budget cleaners such as generic electrical cleaners. And please read the instructions provided with these cleaners, and there is a warning: don't use other cleaners such as brake cleaner or chain cleaner or diesel to clean the sensors. This may cause adverse effects and may damage the MAF sensor in the long term. Just give me 2 seconds, I'll get moving vane meter's explanation on the whiteboard.
12 seconds later.
Now let's discuss about the second type, that is moving vane meter. This is a contact type sensor. In this diagram you can observe the cross section of the intake pipe. This is the intake air part, and this what you are seeing as a L shape is called a vane, and in 3D it will look something like this. And this vane is connected to a electronic component called potentiometer. In short it is called pot, and this side is the engine side. This potentiometer has one more name called variable resistor. This is because as we vary the potentiometer angle or the knob of the potentiometer, the output resistance of the pot varies. This potentiometer will have a different rating such as 10K, 22K or 100K. These are the maximum resistance output of the potentiometer, and on the one side we will measure zero resistance, and on the other side we will have the maximum resistance. In between there will be a linear scaling. Now as the intake air increases, the pressure on the top part of the vane also increases, and thus as the increasing air pressure behind the top part of the vane will move the vane like this. So as the air pressure increases, the vane angle also will increase, and at the maximum air pressure the vane will be parallel to the ground or parallel to the wall of the intake, thus allowing the maximum air flow to the engine. And in this diagram the vane angle is like this. Let's consider this as a 0 degree or initial point. This angle indicates no airflow to an engine, or the vehicle is stationary, and the output of the MAF sensor will be near 0. For some manufacturer it can be 1 volt also. And when we have a maximum amount of airflow, the vane will be like this, and we will have a output of around 5 volts. For this condition the vane is like this, that means highest airflow is there, and the output of the MAF sensor will be near 5 volt. Now let's understand this sequence. Here as the intake airflow is increasing, the vane angle will also increase, thus increasing the potentiometer angle. This potentiometer will be connected to a voltage divider circuit, and as the potentiometer angle increases, the voltage output will also increase. Thus ECU will understand there is an increase in the airflow, and it will calculate the AFR ratio required. It will increase the amount of fuel that is being sent to fuel injectors. Now let's understand disadvantages of having this type of sensor. As we understood, this is a contact type sensor, and we have a mechanically moving vane and the potentiometer. Over a period of time this potentiometer will start wearing out, thus there might be inconsistency in the output voltage. And second one, airflow restriction. As we understood, here this vane will move according to the air pressure. Initially we know the vane will be in this position, thus the airflow is restricted, and only after reaching a threshold air pressure the vane will move. When you are undergoing rapid acceleration and deceleration cycles, this vane will take a little time to move from the initial position to final position. Thus we will have a little lag in the acceleration. Third one is additional IAT sensor is required. That is because here we are getting only air pressure as an input, and we are calculating volume of air. We understood volume of air depends on factors such as temperature, density, altitude. Here we can see the density is directly proportional to the temperature. This temperature will also depend on the altitude where the vehicle is traveling. I hope you understood my explanation on MAF sensor and types of MAF sensor. If you have any doubts or clarification, please let me know in the comments or DM me in the Instagram. I'll be happy to help you out. If you found this video to be informative, please do like and subscribe to this channel. I will meet you in the next video. Bye bye.